I've had a few people ask me how to use a debugger that's built into Espruino, so I thought I'd give you a quick demo. So official Espruino boards all have a debugger built into them, which you may not have realised. So to show you how to use this, I've written a bit of code here. This scrolls text on the display. So this bit of code initialises it. When it's all ready, it kicks off calling this function 20 times a second. So if we want to see how this function actually works, we can't jump into it at the moment. So instead what we'll use is the debugger keyword. So this starts the debugger on that particular statement that you're executing. So if we type in onFrame, we'll enter debug mode, and then we can use step into statement to step into onFrame, and now it highlights the line that we're on. So if we try and find out what's in P, P is currently undefined because move text hasn't yet executed. So at this point we're about to execute this function. You can either step over it, which will still execute it but won't move the line where we're executing into the function, or we can step into, which will move the line up into the function. We can see what the value of marquee pos is. We can step 1 and see that it goes down. And then we can see that there's a check here. Now this is a function call, so it might have a side effect. So the debugger isn't going to execute it automatically as soon as you highlight it with your mouse cursor. Instead, you need to type P on the left hand side to print the value, and then that function. And this will actually call that function and will return the result. So we can see that's 336. So at the moment, minus 197 is greater than minus 336, so that's not going to fire. And we can kind of continue to step through, see what happens. Now if we step past this, it will actually tell us the value that was returned by that function and put it here. We can now see that the value of P is updated, and we can step through. Now g.clear is going to clear the buffer. You can see here that that it's saying g.buffer is it's got something in it, but the first few and last few elements are all 0. If I step over it, you'll see that now it's just saying new array buffer, which implies that the whole buffer is entirely 0. But we don't see that on the screen because it's an off-screen buffer. So for instance, if you were stepping through something and you wanted to be able to debug exactly what was drawn when, you might want to call the g.flip function. And you can do that again just by using P. So P space g.flip, and it will update the screen, and you'll be able to see the result. And we can hit continue running, and it will keep running through the function. It will execute, and then it will continue doing everything else. But often we'll actually want to break in the middle of something, so we can put the debugger keyword where we're interested in the information. So if I put debugger here, and then I hit send to Espruino, we'll see that we have random noise on the screen because this hasn't even been called once yet. This is the very first time. Marquee pos is minus 1001 because of this. And in fact we can step through and we can see that the if statement is now executing that part of the if statement. So it's going to set marquee pos to 84. And in fact we can hit continue running, and we can step through, seeing it running it one step at a time. We can also change values while we run this. So maybe we want to actually set marquee pos to something else. We can just say P again, marquee pos equals, maybe we'll set that to 20 to move it kind of a bit further along the display. And now if we run this again, we'll see it's jumped. If you're interested in the functions that you can use on the left hand side, just type help. So if you're into it, rather than clicking these shortcuts, you can, for instance, just hit step or F to finish, and various things like that. So this can be useful, but you don't want it to break every time, probably. Probably you want it to just break at some particular point. So for instance, you can treat debugger like a normal statement. So you can make an if statement. You can say if marquee pos equals 10. So if I say continue running here, if I say upload, it will upload, it will run until it gets to about here, which is about 10 pixels from the end, and we'll see it stop there. We can do all the normal stuff, or we can hit play again, and it will continue running until it comes around and hits the point where my keyboard says 10 again. So this can be really useful, and actually you can use it for debugging hardware as well, because for instance you can issue commands that actually change the external state of the device here. I happen to know that pin A6 has got the backlight on it, so if I say A6.reset, we can turn the backlight on, or obviously I can turn it back off again. So this can be used for SPI and I2C, and right in the middle of a function that's already doing stuff, you can actually query the state of the hardware device that Espruino is talking to. The other thing you might want to do is you might have a function that just isn't returning, so the whole device has stopped working. So I'll upload this again. I have a function here that I've called broken. So this would sum the numbers from 0 to 9 usually, but instead of I++, I've written I minus minus. So it's going to start at 0 and it's just going to go negative from there. So it's going to get stuck in this loop. So if I type broken, you might think that now the device just isn't working. You can see that the screen isn't updating at all. And the lights would appear to be on constantly, although in reality they're just flickering on and off very fast. So your reaction might be to hit the reset button, or to pull the USB plug out to restart it on devices that don't have a USB button, like the reset button, like this one. But you can actually just type Control and C. So hold Control down, hit C, and then you'll break out of execution. And you're here in exactly the same place. You can try and check what the value of I is, for instance. You can obviously step through all this stuff. You can see it turning one LED on, incrementing the value, turning the other LED, turning that off, turning the other LED on, and so on. You can hit play, which will continue running, and obviously this function isn't going to execute, so isn't going to actually leave. So you'll have to hit Control C to break again. You can hit stop, which will actually completely break execution out of that function. And actually hitting Control C in this window a second time will have the same effect. In which case it will continue working as it did before. But if we run this now, and then I hit Control C to break into it, the other thing you can do is you can change the value of the variable. So we can see that if we look at I, it's actually said it's minus 4037. But if I make I equal to 20 now, and I just step through here, you'll see that it's now exited the function just fine. So not only can you see what's happening, you can actually properly interact with your code as well. So all of this functionality is available on official Espruino boards, including Puck.js, so you can do all of this wirelessly via Bluetooth Low Energy. If you don't have an official board, it may not work. For instance, ESP8266 does not support this because unfortunately the way it's set up, it just can't. But otherwise, I hope this was some help to you. If you like this video, please hit subscribe, like it and share it. I'm producing an awful lot more of these videos, and there are a lot more on the channel as well that you might be interested in looking at. Thanks for watching.